Today we are going to talk about solving multi-step equations with variables on both sides of equation. Before we do that, we are going to check the basic steps that are recommended for solving any multi-step equation. Step 1, if there are any parentheses in equation, we need to use distributive property to get rid of the parentheses. Step 2, combine like terms on each side of the equation if there are like terms to be combined. Step 3, we need to cancel out one of the variables using adding or subtracting. Step 4, we need to undo adding or subtracting of the constant number on the same side of the equation as the variable. So wherever variable is, we need to undo addition or subtraction. And then the last step is undo multiplying or dividing of the number with the variable. So now let's focus on one problem at a time. So the first problem we are going to be looking at is this A that says 3x plus 9 equal 5x plus 3. So what we can actually do, we can just first look at, do we have any parentheses? Do we need to combine like terms? And we can see that parentheses do not exist in this problem. Then the second thing we need to check, can we combine like terms on each side of the equation, which would mean that we have more than 2 terms on each side, and here we have 2 and here we have 2, so there is nothing to combine. Third thing, we need to cancel out one of the variables using adding or subtracting, which means if we have a variable on both sides of equal sign, we have to cancel one. And we can cancel either one of them. Like for example, I could decide to cancel 5x, which I will need to subtract 5x, and then subtract 5x on the other side, because whatever I do to one side, I do to the other side. But to notice, if I do that, I will end up here with negative 2x. Now, I could do that. By all means, that's not a mistake at all. But I don't like to deal with negative variables, negative coefficients of the variables. So what I always look at is, how can I cancel a variable so what's left is a positive coefficient? And I notice if I subtract 3x from both sides, what will happen? These two will cancel out. I will have positive 9 left there. On the other side, I will have 5x minus 3x, which will give me positive 2x, and I like my positive coefficient, and then I still have plus 3. Now notice, I just simply have equation that has 2 steps done to the variable. So I have variable being multiplied by 2, and I have addition of 3. I normally undo my addition or subtraction using the opposite operation. Do the same to the other side. These two cancel out. I have 2x left on that side. 9 minus 3 is 6, and I still have equal sign. Now, undo multiplying or dividing. So I have division, I need to divide by, I have multiplication, need to divide by 2. I need to do the same to the other side of the equation to keep the balance, and I have x is equal to 3. Now notice if I'm checking my solution, I would have to put, instead of x in my original equation, instead of x I put 3, so I have 3 times, instead of x, 3 plus 9 equal 5 times 3, again instead of x, plus 3. If this solution is correct, if x equal 3 is correct, I should end up with 2 sides that have the same final answer, that are equal to each other. 3 times 3 is 9, plus 9, here I have 15 plus 3. 9 plus 9 is 18, here 18. They are equal to each other. I know my answer is correct. Now let's look at B example. B example, we have a variable on both sides. We have 8y here and 6y there. Again, we can cancel whichever one of them we want. I will actually cancel 6y because if I Subtract 6y from 8y, I will end up with a positive variable. So this will give me 2y. I still have minus 3 on that side. I still have equal. These two cancel out, and I have 1 left on the other side. Now notice that's just a plain two-step equation. I need to undo subtraction first by adding 3. Do the same to the other side to keep the balance. And I have 2y left on the left side and 4 on the right side. Now we undo multiplication by dividing, and we have y equal 2. And again, if we check this, if we can do it even in our head. We can just think 8 times 2 is 16 minus 3 will give me 13. And here, if I have 6 times 2 is 12 plus 1, that's 13. So I get the same on both sides of the equation. It's always good to double check our final answer. Now, when we look at example C, notice, when I look at the left side, I have 1, 2, 3 terms. That tells me that actually I might be able to combine like terms. I don't have any parentheses to solve that, but I can combine like terms. So I look at that side and I notice that 3g and 2g, they are like terms, so I could combine them. 3g plus 2g will give me 5g. I still have plus 6 on that side, and I have equal 15. Notice that's just a plain two-step equation. Undo addition by subtracting. Do the same to the other side to keep the balance. These two cancel out. I have 5y equal 15 minus 6 will give me 9. Undo multiplication by dividing. Do the same to the other side. And my final answer is y equal 9/5. I could divide that and I can write it as a decimal. Or I could simply leave 9/5. That would be okay. That's just fine. Now, if you do divide them, then you will end up with 1.8, which would also be correct answer. So now let's look at the last one. When I look at this problem here, I have on the left side of the equation, I have 1, 2, 3, 4 terms. Oh, I need to check what can I combine. If I look at my m's, I have 6m and I have minus 2m. So 6m minus 2m, or keep in mind this can be also addition of a negative 2m, but that's the same thing. I end up with 4m. I also have plus 5 and plus 1 that are just numbers. They are like terms. I can combine them. Adding 5 and adding 1 more would be adding 6. And then I have equal 30. And notice, again, I simply have a two-step equation where I have variable multiplied by 4 and added 6. Undo addition by subtracting. Do the same to the other side to keep the balance. These two cancel out. We have 4m equal 30 minus 6 is 24. And now we undo multiplication by dividing. Do the same to the other side. And we have m equal 6. And again, keep in mind, you can always check your answer by plugging in your solution instead of the variables into the original equation and checking if when you evaluate that, your two sides are equal. If they're equal, you did solve equation correctly. If they are not equal, look for the mistake.